So welcome to RAAONLINE. I am Dr. Jay Kumar and working as Associate Professor in the Department of Pharmacology in a reputed medical college. Today I am going to take you through the process of biotransformation, which is otherwise called as drug metabolism, one of the important steps in the pharmacokinetics. As the name suggests, the drug molecules get metabolized by the liver and then get excreted. So the learning objectives of today's talk will be define the term biotransformation, and we have to see what happens to the drug after the biotransformation with some examples, and what are the sites of biotransformation. Then the different types of reaction like phase 1 and phase 2 reactions. Why the phase 1 and phase 2 reaction are happening, and what are the sub reactions happening in the phase 1 and phase 2 with suitable examples we are going to see, and explain the concept of enzyme induction and enzyme inhibition with examples of drugs. And finally, what is the clinical implication of this induction and inhibition of the enzymes. So as the name suggests, biotransformation, biochemical changes undergone by the drug in the body. So previously we saw pharmacokinetics like absorption and other things. So here what the body does to the drug, that is what it means actually, metabolism. And so if you see, there are different things like, for example, active form of a drug which commonly we consume and gets converted to inactive form. This is majority of the drugs will follow this pathway, okay. And then the lipid soluble of the drug will be converted to water soluble property, so that because the water soluble property of the drug will be useful for the excretion of the drug. And then the reabsorbed, the drugs that gets reabsorbed will, as a metabolite, it cannot be reabsorbed, because once it becomes water soluble, it cannot pass through the lipid bilayer for reabsorption. So this is the important things in a biotransformation. So active form should be converted to a inactive metabolite, and lipid soluble drug should be converted to water soluble drug, and then the drugs that are reabsorbed for producing the therapeutic effect, so should not be reabsorbed, then only it can be excreted after the therapeutic effect. So why biotransformation? As I said, to be converted to a simpler hydrophilic compounds so that they are eliminated and the action is terminated, because we don't want the drugs to produce its effect for a long duration of action. It has to produce effect for a short duration of action, then it has to get metabolized so that it can be eliminated by the kidney. This is what the important concept of biotransformation. And most drugs are excreted by the kidneys. And for renal excretion, if you see, the important points is the components what they should possess, a drug molecule should possess is, they should have small molecular mass and they should be polar in nature. Polar means it is water soluble, and it should not be fully ionized at body pH. So our body pH, if you see blood, the plasma pH 7.35 to 7.45. So basically the drug should have a small molecular mass and it should be water soluble and it should not be fully ionized. And most drugs are complex and do not have these properties and thus have to be broken down to similar products. So for example, majority of the drugs, the active form of the drug when you give, it go and binds to the site of action, then it produces the therapeutic effect. After some time, they dissociate from the binding, receptor binding, and then reaches the liver for metabolism. So finally, the lipid soluble drug will be converted to active, either a metabolite, which most of the time it will be inactive, and then it goes the phase 2 reaction to become as a water soluble drug so that it can be excreted by the kidney. This is what the drugs should follow the steps. So drugs are lipophilic in nature, so which is good for absorption, okay, and then through the mucosa it can absorb, reach the site of action, and they strongly bound to the plasma proteins. So this is another important thing. When a drug molecule binds to the plasma proteins, more percentage of drug when it binds to the plasma proteins, then the free form of the drug present in the plasma will be less, and as a result the drug metabolism can be very less actually. So this is another important point, because the duration of action can be prolonged if a drug has high plasma protein binding, and this property also stops them from getting eliminated. As I said, Okay, because only the free form of the drug, after producing the therapeutic effect, it reaches the liver for metabolism. But here, majority of the drugs, if it is having high plasma protein binding, then imagine it is the free drug is very less amount of free drug is available for the metabolism. Okay, so when and how the biotransformation can occur? So normally we know that this biotransformation is a process that occurs between absorption and elimination from the kidneys. So in between these two, like absorption and the excretion, that is where your metabolism occurs. And the drugs administered orally can undergo biotransformation in the intestinal wall. This is very less amount of drugs can get metabolized in the intestinal wall. For example, enzymes like esterase, so which is present in the intestinal mucosal wall. So some drugs, few drugs, when they come to the intestine, they get metabolized by this esterase enzyme. So this is also another important minor route for metabolism. So biotransformation, as I said, the active drug, very minimal of the active drug can directly excrete without any process. But majority of the active drug, they undergo phase 1 metabolism to get inactive compound and finally excreted. Okay, and then if you see the prodrug, which is another important concept, prodrug is nothing but it is an inactive form of a drug. When it goes inside the body, it gets metabolized to convert as an active form, and that is an active metabolite to produce the therapeutic effect. This is a prodrug which is very important in the metabolism process. And this sometimes after the active metabolite is formed, it undergoes conjugation reaction, which comes under the phase 2, and finally it gets excreted. So if you see this process, all these active or prodrug or whatever it may be, finally the drug has to the lipid soluble drug has to be converted to the water soluble. To convert the water soluble, it has to undergo the process of conjugation and to make it water soluble by the phase 2 reaction, and it gets easily excreted by the kidney. So this is what the important thing.